So we're going to continue. Last time we covered up to number 7, right? Let's continue on this worksheet, review sheet. Okay. Problem number 8. We want to find the area below standard normal curve in the following range. And what we're looking for? Below 0.05. Okay. Now when you work on these problems, first thing you do is draw a picture. Okay. Standard normal curve. That's what we're looking for. So or working on. So this is standard normal curve. Stand-up is 0. Okay. Then we're looking for area below 0.05. That means what? Everything below it. 0.05. 0.05 is a positive number, so it's to the right of 0. So what you need to do is check the standard normal table, and I find the area from 0 to 0.05. That actually will be this piece. Right? And then you know this piece. What is this? 0.5. Right? So 0.5 plus that, you will get the answer. Okay, so what you need to do is look up a standard normal table and find for that. Can you do that? Let's look at a table. Let's look at a table together. Okay. It was 0.05, right? 0.05 actually is this one. 0.0 and second decimal place 5, so it's 0.0199. Okay, 0.0199. So let's go back to. So this piece here is 0.0199. So what's the total area below 0.05? It'll be 0.5 plus 0.0199. So it'll be 0.5199. Since this is the 0.0199 we got from the table, right? And this is 0.5. Add them together. That's total area below 0.05. Okay? Should be simple, right? You just have to practice, though. Next is between negative 1.23 to 2.54. So again, we're going to draw a picture. Mark the 0, so you know how to mark these 2 points. Negative 1.23 should be on the left, and then 2.54 should be on the right. And we need this piece. We also need this piece. Okay? How to find the area for this piece? Well, I use a z-score 2.54. So if you look at the standard normal table, 2.54. 2.5. Let's go down 2.5. 4. This is 0 and 1, 2, 3, 4. So it is 0.4945. Okay? That's 0.4945. That's this piece only. And we need to look for this piece. What z-score should we use? 1.23, right? You use 1.23. Due to the property of symmetry, the area from 0 to 1.23 is the same as the area from 0 to negative 1.23. So you look at the table, 1.23, 1.2, and then 3, you get 0.3907. Okay, so 0.3907. 0.3907, and that's this piece. So what will be the total area from negative 1.23 to 2.54? That will be simply just the sum of these two numbers, these two areas. Okay, what would that be? That would be 0.8852. Right? Okay? Okay, let me explain this again. We're looking for area under the standard normal curve from negative 1.23 to 2.54. Okay? We can find this area here from the table using z-score 2.54. Okay, and that's 0.4945. To find the area from 0 to negative 1.23 is the same as finding area from 0 to positive 1.23, since the curve is symmetric with respect to 0. Okay, so we just use z-score 1.23, look for area from 0 to 1.23. It's 0.3907. So the area from 0 to negative 1.23 is also 0.3907. Okay, if you do have a 1.23 here, the area like that up to this point is 0.3907. But what we're looking for is really this one, and this piece should be the same as this one. Okay, if you have a z-score negative. So we know how to find this area is 0.3907, and this area is 0.4945. And we like the total area from negative 1.23 to positive 2.54, right? So we need to add these two together and add up to 0.8852. So the total area under the sternal curve between negative 1.23 to 2.54 is 0.8852. Okay? Any question? Let's look at this other one. Get wider. Let's say we assume that YSU students' GPA follow a normal distribution with a mean score of 2.7 and a variance of 0.49. Find the percentage of YSU students having GPA above 3.5. Okay, so we know that GPA follow a normal distribution. Mean is 2.7. They didn't give you standard deviation, they give you variance. Well, but if you know variance, you know standard deviation, right? So the GPA actually follow a normal distribution with a mean 2.7, but standard deviation is what? Square root of variance. Variance 0.49 is the standard deviation should be 0.7, right? If you take square root of 0.49, it's 0.7. 0.7 times 0.7 is 0.49, okay? So you got to do that, right? You don't use a variance to do the standardization, right? That's a trick, okay? So then, okay, so you can draw this distribution curve. Normal distribution GPA with a mean 2.7. This is a normal distribution GPA. And we'd like to see what proportion of them have GPA above 3.5. So if this is 3.5 to the right of 2.7, and that's what area that's we're looking for. If we can find that area, that's the proportion of people whose GPA above 3.5. Okay, but this is in the regular normal distribution. We're solving proportion that is higher than 0.35. It's the same as finding the proportion under the standard normal distribution that is above standard score of 3.5. So we standardize 3.5 by using 3.5 subtract mean divided by standard deviation, right? Which means I'm going to find a z-score for 3.5. Z-score for 3.5 actually is what? 3.5 minus 2.7 over 0.7, which is, what would that be? 0.8 over 0.7, right? What would that be? Anybody? Maybe 1.14. Okay. 1.14. 2 is good enough because the z table only give you reference for z-score only up to second decimal place. So just use 2 decimal place. Okay? So, and of course, this will be 0 here when you look at the z-score version, right? Then what you do, you cover this up, assuming you have a normal distribution. Cover this up and try to find the area above 1.14. Okay? So that's finding the area above 1.14 in the standard normal distribution. So what you do, look for the standard normal table. Actually, look for area from 0 to 1.14. What would that be? 1.14. Let's look at the standard normal table. 1.14. So it'd be 0.3729. Okay? 0.3729. And 0.3729 is where? 3729 is this area here. Right, area from 0 to 1.14 is what provided in the table. So what you need to do is use 0.5, subtract this area, 0.3729. You get 0.1271. That's it. Okay? However, I ask percentage, you're going to convert that to percentage, 12.71%. And that's the answer. So as I say, every time you do these problems, you want to draw a picture. Right? Draw a picture will give you a better sense as to what kind of area. What should you subtract, should you add, and whatnot. Okay. Find the 65th percentile of this distribution. 65th percentile. Okay. Doing this, again, I would draw a picture first. I would start with standard normal distribution. I want to find the z-score for 65th percentile. 65th percentile should be somewhere here. So the total distribution below it is 65%. Okay? If the total distribution below this is 65%, then I will have actually below 0 is 50%, and here it will be like 15%, right? So the total is 65%. I find this 15% in order to help me to find the z-score for this point. Okay, so if that's a 15%, if you have area that's 15%, how do you find the z-score? You look up this standard normal table. Find 15%. Do I have 15%? Well, here it's close to 15%. Let's go further to the right. 15. Okay, so which one is closer? 0.1480 or 0.1517? Which one is closer? Actually, this one is closer. 1517 is closer. Okay, what's the z-score correspond to it? 1517 z-score is 0.39. So that z-score is 0.39. If the area from 0 to that z-score is about 15%, then that z-score is 0.39. Okay? So I can fill this in, right? This z-score for this is 0.39. Now I can find my 65th percentile, right? /65th percentile has a z-score of 0.39. That means what? This 65th percentile is 0.39 standard deviation from the mean. So the mean is 2.7. So we have 2.7 plus z-score times standard deviation of 0.7. Okay, so 2.7 plus, anybody can help me? 0.39 times 0.7. 273, right? 0.273. So it'll be 2.973. So if you have a z-score, I'm sorry, GPA, right? That is 2.973. You're at the 65th percentile in this GPA distribution. Yes. 0.39. You're saying that, how do we find this? Okay, because area from here to here is 0.15. Okay, that you know, right? And you use that as an area to look for a z-score. Well, area over here is 15% or 0.15. What would be the z-score such that the area from 0 to that z-score is 0.15? Well, you remember the standard normal table tells you the area under the standard normal curve from 0 to some point away from 0. Okay, if you have that z-score, you can find that area. Now a problem is you have this area first. How do you find the z-score such that the area between them is 0.15? Okay, you look up the table. This kind of problem, you look up the table, find the area first. Okay, let me explain this again to you. Right? Maybe grab another piece of paper. This is important. Okay, I have this standard normal curve. Now, what's a z table for? Standard normal table for? Standard normal table tells us area under the standard normal curve from 0 to some z-score, right? Away from 0. If you know the z-score, you can find this area because this area is given in the table. Also, if you know the area first, you can use the area to find the z-score. Okay? I come back to this table here. If you have the z-score, and you can find the area from 0 to that z-score. If you do have the area first, right? This is the area from 0 to a z-score. Then you can come back looking for a z-score. For that particular problem, the area is about 15%, right? So this is 15%. What would be the z-score? 0.39. Okay? 0 area under the curve from 0 to 0.39 will have an area about 15% or 0.15. Okay, so if you do have area as 0.15, then the z-score will be about 0.39. Okay, good. So that's how we get this, solve this problem, right? Now, if 144 students are selected, what is the probability that average GPA is less than 3.0? Well, this one required sampling distribution. This is probably a question related to sample mean. Okay, so we need the probability distribution for sample mean first. What's the probability distribution for sample mean? This is another measurement that we're interested. We're interested in sample mean. How is sample mean distributed? Since we have a relatively large sample, 144, that's a large sample. The central limit theorem says what? If you do have a large sample, sample mean will be normally distributed. So we know the shape. Okay. And what is the mean of this distribution of the sample mean? We learned that mean of a distribution, sample mean will be sampling distribution of the mean will be the same as the mean of a population, which is 2.7. And what's the standard deviation for the sampling distribution of the mean? Or what's the standard deviation for the probability distribution of the sample mean? It'll be the standard deviation of the population divided by square root of sample size, right? Population standard deviation is 0.7. Divide by square root of sample size. Square root of sample size. Sample size is 144. So you got to do this computation. It's 0.7 divided by 12, though, right? That will be a number. Let me see. What would this be? That's a small number. 0.0533. Okay. Let me just keep it like that, right? 0.053. So I have the standard deviation and the mean. Now I can solve this problem. First, I draw a picture of this normal distribution. And this normal distribution is for sample mean now. Okay? Sample mean is normally distributed with mean 2.7 and standard deviation 0.53. And we like to find out what proportion of distribution that is above 3. I'm sorry? 0.058, is that right? Okay, good. Okay, now how do we solve this problem then? We know that mean and standard deviation, what we need to do. Originally what we want to solve is the proportion that is greater than 3.0. It's the same as finding the area under standard normal curve above the standard score of 3.0. So we use 3.0 minus 0.27 divided by standard deviation. Okay? That is, we find the z-score, right? Z-score for mean is 0. Z-score for 3.0 is this. Whatever this is a 0.3 divided by 0.05. It's going to be a large number. Yes? Oh, less than. I'm sorry, less than. I'm sorry. Okay. I'm doing it too quick. That's this one. Okay. So I got to do this. Thanks. This is less than. Okay. Less than. So I reverse the sign. So this is what we're looking for. Okay. Now how do we find this then? We got to find a z-score here. What's the z-score here? That's a result from this computation, right? It's like a 5.17. That's a large number. Okay? If you have a z-score that's 5.17, what's the area between 0 and that z-score? Let's look at this table. It's going to be very huge because you know that for the standard normal distribution or any normal distribution, most of the distribution within 3 standard deviation. This z-score is 5, so that actually beyond the table. You have z-score reference to only to 3.09. Above 3.09, the table suggests that you're going to always assume that you have a 0.4999. Okay, so the area from 0 to 5 is 0.4999. But we're interested in actually everything below z-score 5, or 5 point whatever. Let's go back to that slide. So this piece here, just this piece from here to here, it's 0.4999, and this piece here is 0.5. So you got 0.5 plus 0.4999, so it'd be 0.99. That's almost 1. Okay. Some of the textbooks suggest that if you're beyond certain, then we're going to assume that it's approximately 0.5. Okay. So almost 100% of the students with GPAs below 3.0. Okay, but that's not true though, right, for YSU, but it's just an example. Any question? Okay. Good. No question? Let's look at this next example. This is an example related to expected value. Okay. Let me move it up. The probability distribution of 6 faces of unbalanced die is given in the following table. A game is designed so that player will lose $2 when an even number occurs and win $1 when 1 or 3 occur, and win $3 when 5 occur. Okay. With that, you can actually just make your probability distribution table right there, right? Anytime you get a 1, you win $1. So that's really $1 there. And get a 2, you even 2 or 4, you lose $2. Right? Or even number actually, 2 or 4 or 6, you lose $2. And what's the chance of getting a 1? It's given in a table. The chance of getting 1 or chance winning this $1 is 10%, 0.1. Chance of getting 2 is 0.2, or chance of losing this $2 is 0.2, right? Chance of getting 3 is 30%. Chance of getting 4 is 10%. Chance of getting 5 is 20%. Chance of getting 6 is 10%. And you, of course, you like to check first of all to see whether you add this up, it is 100% or not. If you add this up, it's not 100%. That means what? This is not a right probability distribution. There's something wrong. You cannot use it to do anything. Okay, but it happened that it satisfied the basic rule of probability. Then how do we do this then? Let's answer the first question. What is the probability of winning $1 in this game? Winning $1, there are so many situations that you'll win $1, right? Either this, or this, or this. Chance for this is 10%, this is 30%, this is 20%, right? So chance of probability of winning $1, yeah, because it is what? Probability of getting 1, or getting 3, or getting 5, right? Either one of these, maybe I should say this. That's the probability of getting 1, or 3, or 5. Okay? And how do you solve this problem? Just add the probability for each of this. This is 0.1 plus 0.3 plus 0.2. So it would be what? 0.6. 60% chance that you will. Yes?
I just want to know why you're putting all the other amounts in when it's only asking for $1.
$1, there's many situations for winning $1.
You should reword it and say, like, how many possibilities can you get $1 or more? That might be easier. Because that would just work for the number 1 and number 3 for $1.
Oh, I'm sorry. No, this is not $1, right? Okay. I'm sorry, only 1 or 3. So it'll be like this. I'm sorry. Yeah. Okay, yeah. Sorry. Yeah, for exactly $1. Okay? Good. Thanks for bringing that up. Actually, only these two instances, $1. I missed that, right? This is $3. Okay, good. Good question. So that's 0.4, 40%. Wonderful. That means that you understand it very well. That's good. Okay, so let's look at the next one. What's the probability of winning $1 given that odd number is rolled? So this is a conditional probability. Okay? Winning $1 given the odd number is rolled. Well, that's a probability of getting odd number divided by probability of winning $1 and getting odd number. Right? The probability of getting odd number will be these. 0.1 plus 0.3 plus 0.2. That's a probability of getting an odd number. Right? What's the probability of getting an odd number and $1? That's these two. That's the probability. 0.1 plus 0.3. Okay. Just based on the rule. So this is 0.4 divided by 0.6, that's actually 0.2/3. That's 0.67 around. Okay. If you got an odd number, what's the probability? You win $1. Okay. You can look at it this way. What's the probability of getting odd number? Chance of that, well, getting 1 or 3 or 5. Chance of that is what? 60%. Among those 60%, right? What's the percentage of winning $1? That's those 40%, right? 10% here and 30% here. So it's 40% out of the 60%, right? So you can say 40% out of the 60%. Yes. Mm-hmm. Mm-hmm. Table.
Are we gonna have
Mm-hmm.
to figure that out, like say in a problem or whatever? Or
Maybe I will just let you build a table, right? It all can happen. Ask you to build a table maybe is a little bit harder for some of you. Okay, but it'll be good practice because in practice, you will have to do that yourself. Nobody will build this table for you. You have to just write it down. Okay, people may tell you, well, the chance of this is what, chance of that is in word, right? And you will have to just set up your table and to do this yourself. Okay. Now the table can be written in so many different ways. Okay. For this particular problem, I can have a table like, because I'm just probably interested in losing $2 or winning $1 and winning $3. I could have just these three outcomes of interest. And what's the chance of losing $2? 30%. I mean, sorry, not 30%, but 40%. Here, 40%. Winning $1, 40%. Winning $3, 20%. I could have a table like this, because I really not interested in either getting 1 or 2 or 3. I'm running this casino. I'm only interested in the amount of money that I win or lose. And I may have a table just like this. I have only these three outcomes of interest. Okay? Then you can simplify this table a little bit, though, if you like to. Okay? Let me tell you this. I would just give you a table, okay, so that you don't have to worry. But but in practice, you got to know how to set this up for yourself. Okay. Now let's look at the last one. What is the expected value of this game? Now you can do it with this table or with this table. With this table, it'll be easier to do because you only have 3 terms or 3 products. With this, you have to do 6 products, right? Remember how to do the expected value or the mean? Right? Sometimes people use this notation mu, and that's sum of product like this, right? Values times probability, value times probability, and so forth. So you may want to create a column like this, a row like this, and you have 0.1, negative 0.4. This is 0.3. This is negative 0.2, 0.6, negative 0.2. Right? These are all products, and then find the pardon? Just this. Right? Multiply these, right? Value, because you're interested in value, right? Amount of money you win or lose, and what's the chance of those? Okay, so you multiply these products, multiply these pairs of numbers. Okay, and then add these products. So you will have to add this 0.1 minus or plus negative 0.4 plus 0.3 plus negative 0.2 plus 0.6 plus negative 0.2. So you get, what do you get? Actually, 0.2. Okay? If you do get a 0.2, do you get a 0.2? I think so, right? So you get a 0.2. If it is really 0.2, what does it mean? Is this a good game for players? Yes. Okay. This casino owner maybe just try to give customers some incentive, right? Design a game that you always win, so you will come back again, right? At 20 cents per game on average. So you play 100 games on average, you're going to earn $20.
So you're always going to multiply the outcome
Yeah, the outcome and probability. You do the outcome times probability, and then add these products. Remember, this is kind of the weighted average. If you remember earlier when we talked about mean, we talked about weighted average too. Okay, so this is like a weighted average, but this is average. How to interpret this number? You tell people that if you continue playing such a game, you expect to win 20 cents or 0.2 of a dollar per game. Okay. And that's how you evaluate this game. That's how you evaluate an investment, right? Or that's how you evaluate maybe the insurance policy, okay? And a lot of things that you can do with this kind of.
Did you already make the test?
Almost done.
How many questions do you think?
Probably around like this. Okay. You have to practice though. You don't want to spend like 10, 20 minutes on one question, then you will be in trouble, right? If you practice enough, right? Each question probably just take you probably a minute or less, right? Then you will have time to check, and that would check your answer, okay? Some may take a little bit more, maybe more than a minute, but don't spend more than 5 minutes actually on the problem, right? But it requires practicing though. Okay? Good. Okay, if that's the case, let's see if we can do some more questions. How about this? Okay, you can read it, I think. Let me just put this here. Not quite clear, huh? Can you read? Let's try this one. The number 4. What percentage of area under standard normal curve is between -2 to positive 1.5? Okay, so this is a standard normal problem using a table finding area under the curve. That should be easy, right? Number 4 is what I ask you to do. And if you got those two numbers, -2 to 1.5, I'm going to show you the table. Okay? -2, 1.5. Okay, that's good. I think that's good enough. Okay, I'm going to flip it to table now. Okay? -2 to 1.5. Just draw a normal curve and mark these 2 points. That's your question, right? Let's look at this table. Can you see it? Okay. -2 and 1.5, they're all here. Right? Done? Good. So what's the answer? Anybody has the answer? 0.9104? Good. 0.9104. How do we do that? 2, you get a 0.4772, right? 1.5, you get, is that 1.5? Yeah, you get 0.4332. 0.4332 plus 0.4772. you get 0.9102. 104. Okay? 0.9104. Okay, you have 0.4332 plus 0.4772. Okay? How about look at the other problem? Here, let's say maybe this one. Okay, just do the part A. See if we can do part A. We have distribution of insect, the lengths of insect. Is that right? Pardon? Can't see it?
No, the whole thing is cut off.
Okay. Okay. The lengths of particular insect follow a normal distribution with the mean 3.1 cm and the variance of 0.5 cm. What percentage of this particular type of insect are more than 3.2 cm in length? Okay, so what you need to copy down is mean is 3.1. Variance 0.5, that means standard deviation is what? Square root of 0.5. Be careful, right? Whether I give you standard deviation or variance. If I give you variance, you have to take square root. If I give you standard deviation, you can just go ahead and use that for standardizing. Okay? And so what percentage of the insects that have lengths more than 3.2? When we do the test, you need to bring your own calculator. Right? Don't forget your calculator. And make sure you sleep enough. Don't stay up too late and then drink enough water because it's a flu season, I guess. A lot of people catch cold, right? So be careful. Have more fruit and then drink more water. Have enough sleep, right? Otherwise, you'll be. And also wash hands. Right? Wash hands as often as possible. If you finish that, do you want to try the part B? What's the 30th percentile? Okay. What will be the 30th percentile? Yeah, sure. If you have the table, question copy, then show you the chart. I think I might have done that already. I put a copy of this table on the web, so you want to print a copy, right? Be handy to you whenever you're doing in-class activity or doing your homework. Just go there and download and print a copy. Okay, let's do it. Okay, so this one, let's draw a picture. Mean is 3.1. Standard deviation is square root of 0.5, right? We want to find a percentage that's greater than 3.2. What would that be? This is the original distribution. You want to find a z-score for these. Z-score for this is 0. Z-score for that, 3.2. I'm sorry, not 3. Yes, 3.2 minus mean 3.1 divided by, actually need to be square root of 0.5 since 0.5 is variance. Okay? So you get 0.1 divided by square root of 0.5. Anybody can help me with this? What do you have? Pardon? 0.707, so I'm going to round it to 0.71 since the table for z-score only up to second decimal place. Okay? Then you will use a 0.71, look at the standard normal table. 0.71, 0.71, that's 0.2611. Okay, 0.2611. What is 0.2611? It's here, 0.2611. Now we're looking for a percentage that is greater than this number. So we'll be using 0.5 minus 0.2611. Point 1 divided by point. Oh, is that right? Oh, okay. I thought, okay. This is 0.71? Okay, good. Confusion. Okay. So 1 divided by 0.71, 0.1 divided by 0.71. What would that be? 0.14 what? So it'll be 0.14 then, right? Good, thanks. 0.14? Is that 0.14? Okay. So I'm sorry about this. So you actually look for 0.14 then. Okay? So let's go back to the table. 0.14. 0.14 is 0.0557. Okay? 0.0557. So 0.0557, this is 0.0557. That's this piece. So we'll use 0.5 minus 0.0557. You get 0.4442. Okay? Is that right? Is that correct? Okay, good. And the next one, do we have time? Yeah, we have time. Okay. The length, the 30th percentile. 30th percentile, what do you do? This is part B. Okay? That's part A. 30th percentile, first you have to find the z-score for the 30th percentile. If it is 30th percentile, that z-score is on the left tail. Okay? 30th percentile means what? This area is 0.3 and this area is 0.2. You have the area first, you want to find the z-score. What would that z-score be? Okay? You have area is 0.2. Find the z-score, right? You want to use a standard normal table. 0.2, which one is closer to 0.2? The 0.1985 is closer to 0.2. The area is closest to 0.2, so the z-score is 0.52. Okay? 0.52. So this z-score actually will be what? Negative 0.52. Okay? If this is negative 0.52, what will be the actual score then? The actual score will be mean 3.1 minus 0.52 times standard deviation square root of 0.5, which is this. So it'll be 3.1 minus this whatever thing is. This number should be about 0.35, right? So it'll be 2.27. What am I doing? 2. I can do subtraction. 2.75, right? Okay? So that's your 30th percentile. Okay? Does it make sense? Okay. Knowing the z-score, you know how many standard deviation is that value away from mean. Z-score is negative 0.52. That means what? Your value is 0.52 standard deviation from the mean, but it's to the left, so you subtract from mean. This one is square root 0.5, the standard deviation. Okay? In order to find the score, you use a mean plus z-score times sigma, right? Your z-score is negative this is negative 0.52. This one is square root of 0.5, which is 0.71. Okay.
That's not what I'm talking about. Over on the chart.
Yeah. Yeah.
Where did you get those two numbers, 0.7 and 0.2?
On the chart, point.
Right there. How did you get those numbers?
This is z-score.
0.2 or 0.3?
This is 30th percentile, so area below is 0.3. Area from here to 0.2.
0.7.
No, this is z, and this is 0.2. Area from here to here. Okay. Okay. Good. Good. Okay.
I was really confused. I was like, 0.7 doesn't make sense.
Okay. Good. Any question? Any more question? Okay. See you on Friday in the lab. Right.